Hello, today we have Pre-Calc lesson 35, changing coordinates, the name of a number, and the distance formula. Change in coordinates is kind of an interesting idea. Coordinates, oh goodness. So, it's a two-step procedure. We write down the final coordinate, and from this number we subtract initial coordinate, and it basically represents a directed distance. So here's our example for this. If we're given the points P1 is negative 3, 2, and P2 is negative 4, negative 5, what do we represent by negative 3 minus negative 4 and negative 5 minus 2? If you notice, negative 3 and negative 4 are our x values. So this shows us the change in x moving from P2 to P1. And negative 5 and minus 2 shows us the change in y moving from P1 to P2. That's kind of all that we have. Change in number, change in coordinates, that's what it looks like. Now let's look at the name of a number. Okay, we have our change in coordinate, what we just talked about as delta C. Okay, and in this little formula we're going to write the final coordinate first and the initial coordinate last. And we're writing delta C is going to be the final coordinate minus the initial coordinate. So let's do an example with this. What is the number that is 2/3 of the way from 3 to negative 7? So our number, we start at 3 and we're going 2/3 of the way times delta C. Well, delta C, you put your final number minus your initial number. So this gives me 3 plus 2/3 times negative 10, which gives me negative 11/3. That is the number that is 2/3 of the way from 3 to negative 7. Okay, let's do another example of that. What is the number that is 5/11ths of the way from 3 1/8 to negative 3 5/8? Now, I know your book continually insists upon using mixed numbers. We do not use mixed numbers, so we need to change those. Okay, so we know that 3 times 8, right, gives us 24 plus 1, so we will have 25/8 plus 5/11ths of the way. We're going to do our final number, so negative 3 5/8 will give me negative 29/8 minus 25th eighths. So I have 25th eighths plus 5/11ths times negative 54 eighths, which gives me 5/88. This is just a calculator problem at this point. You just plug it in. All right, now let's talk about the distance formula. The distance formula is finding the distance between 2 points. We derive it from the Pythagorean theorem. I'm not going to show you that though. I'm going to just give you the formula. The distance is the square root, if we're going from x1, y1 to x2, y2, the distance between those 2 points. We'll have x1 minus x2 squared plus y2 minus y1 squared. Now, this is the same thing as if you were to write it y1 minus y2 squared plus x1 minus x2 squared, or the same thing as y1 minus y2 squared plus x2 minus x1 squared. All of these are the same, and it doesn't matter which one you use because the terms are squared. Okay, it will be consistent no matter what. It's the distance between points and it's squared, so it gets rid of our negatives we might have. This is the one I typically use, but you can use any of these versions. So let's do an example with it. Actually, I think it's example 4. Find the distance between 4, negative 2 and some point x, comma, y. So we plug it into our distance formula. Our distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. There you have it. That's all. That is the distance between 4, negative 2 and xy. Now we're going to use this a lot in a couple lessons to come. We're really going to get into the distance between a point and a line. But this is a really good place for you to start. And that's also a really good place for our lesson to end.